All right, hello everyone. Thanks for coming out again. We're gonna get started. We have a lot of content we want to get through today. All right, so first things first, just some logistical stuff. So make sure you're enrolled on Student Center for this class. Has anyone had any issues with enrollment? If you have, just come talk to us, post on Piazza. We're having some weird issues with the deadline being pushed around and we weren't very clear about it, so yeah, just let us know. And then just as a reminder, all the resources, so like the lecture code, the like assignments, everything will be like posted up on the website every week, so like we'll update it as we go. And second thing is, just to reiterate on the grading policy, you do have one drop throughout the whole semester, but you do have to do the first and final projects. Those are the only required ones. But other than that, you have one drop for the whole semester. It won't hurt your grade. And then for extensions, just let us know at least 24 hours in advance. We understand that this is an extra class that you're taking like more for your own interest. And so like we're very understanding of that, but just let us know so we can handle that. Okay, so we're going to go through a quick review of what we went over in Lecture 1. So just to reiterate, so if we have a structure called a task, what do you think would get printed to the console if we ran this code? I'll give you guys a little bit of time. Does anyone have any initial guesses? Yeah.
Buy food.
Buy food. Well, so there are two print statements. What will be printed in each?
Both.
For both? Okay, that's a good guess. Yeah. Sorry, could you repeat that? Right. And so why do you say that they would be different? That's correct. Yeah, so the reason why it ends up being different is because, as we talked about, structs are, I think it's value type, as opposed to classes are reference type. And so when we have that assignment of var task B equals task A, it's copying over all the values that are in task A and creating a new object for task B. But that would be the case if task were a class, and that may... Oh, that's the answer. Okay. So, okay, I guess answered this one, but what if we change task to a class? Yeah, I don't know, I'm just going to say it. It ends up being buy food, because in this first assignment, when we say task B equals task A, instead of copying over all those values, it's copying over the reference that task A is pointing to. And so when we change the object that it's referring to, it's changing the object that both are pointing to. I don't know, that was a little weird, but hopefully that was clear. So what do you guys think would happen if we run this code? I'll give you guys a little minute to go through it again. Any guesses? Does anyone see anything wrong with this code? Do you have a guess? Yeah.
So when it says int equals A, since A is nil, it won't work.
That's true. Yeah. Yeah, so this should actually not be able to compile. And so I guess a little clarification on that. So A is typed as an optional integer, and so we know that it could be either nil or a real value. And so when we're trying to assign that optional to B, then it's going to say that like because it could possibly be nil, we're not accepting it as a proper assignment. I guess, do you think this error would exist if we had A equals 10? Yeah, so that's correct. It's still, the type of A is still an optional int, so at some other time it could be cast to nil, and it would still cause the issue. Dope.
All right, we're going to move on to the new topic that we're talking about today, and that is starting with UIKit. So UIKit is a framework or a library that was created by Apple that provides objects that you'll use when you're building iOS apps. So you can think about these as objects like labels that you see in apps or buttons that you see in apps, or more generally, like the entire screen. There's a component for that that's called a view controller. So a UI view controller, you can basically think of as one entire screen in your application, so that entire like rectangle, and then you can add additional objects on top of that. And then it'll maintain kind of like this hierarchy of views, so as you put stuff on top, it literally will build up layers like that. And then every app that you have will have at least one view controller whose content is the size of the entire screen or window, and that will be known as your root view controller. So this, if you think about the stack, would be at the very, very bottom, and it's kind of like the backdrop or the base of your application. And then there's also a class called UI views, and all the little objects that you think about in terms of like user interface, so images, buttons, labels, any sort of chunks of text, those all have their own components that you'll learn how to use, and those are all subclasses of UI view. So if we look at this screenshot of Uplift, you can kind of take note of where different components might be used. So when we see like the big title, that's just like one line of text, you'll commonly just use a UI label for that, versus like on the bottom, there's a really long chunk of text, and you'll use something called a UI text view for that. And then there's other things like image views that can display images, and then buttons that you can register like functions to run when they get tapped on. And then the second part involved with using UIKit is AutoLayout. So AutoLayout is how you can lay out objects on your screen. So you can do their position as well as their size. And then it's really kind of like a key of AutoLayout is that it's called relative because you can assign rules between different objects. So you can set rules relative to one another. So say I have a button and I want it to be 10 pixels below the label that's above it. So that's the button is being constrained relative to the label. And then every view that you have is defined by a set of anchors that you set those rules on. So every view will have anchors that describe its width and height in terms of size. And then for the position, there's anchors for the center point, both in the X, so horizontal direction, and the vertical direction, as well as the top and bottom edges, and then the left and right edges as well. There's actually, on the slide, we have leading anchor and trailing anchor because they kind of distinguish between left and right because there are left and right anchors, but in cases where there's apps or languages that are read like right to left, so reverse of what we commonly use, if you use leading anchor and trailing anchor, that'll flip those accordingly to match the reading direction. Does the distinction between left and right and leading, trailing make sense? And then kind of to visualize all of these anchors, we have this button. So you see that height and width are used for the size, whereas the other ones are just the edges and don't describe like the size of the thing. So we have the center position. Yeah.
So is an anchor basically just like a type of field inside the class?
Yeah, it's a property of, it'll be a property of any UI view subclass. So a button or a label text field. Cool. So we have the center X and Y position, and then leading and trailing edges and top and bottom edges in addition to the height and width. Cool. And then if we think about a view controller's root view, so the view that's the base or backdrop of your app, those also have anchors, so you can kind of constrain things relative to the top and bottom of your screen, as well as the leading and trailing edges of the entire screen. So there's just more examples of UI components. So an image view, a label, a button. So you can kind of like imagine an app in your head, and eventually you'll probably get familiar with enough components where you can kind of like look at it and break down what classes they might be using. And then before I was saying we want to constrain things relative to each other by setting rules. So these rules are known as constraints, and they're defined between a view's anchor and the anchor of another view or the screen. So for a visual, let's say I want the top of the song title to be X number of pixels from the bottom of the album cover. I can set a constraint or a rule on the song title's top anchor to be that number of pixels below the bottom anchor of the image. Does that make sense? Yeah.
So what happens if you have multiple constraints and like the element doesn't fit?
So if you have multiple, well, there's either it'll just like crash and won't show your elements because they're like, oh, there's too many overlapping that like it doesn't fit, or something just really weird could happen with it reassigning priorities and stuff like that. All right. So there's actually one special case when you're constraining a object relative to the top or bottom of your screen. Because if you think about like newer iPhones, they have that notch at the top that'll block off the top part of your screen. So if you constrain something relative to like the very top of your screen and didn't account for that notch, you could inadvertently put something like behind it and then it wouldn't actually show up. So there's actually something called the Safe Area Layout Guide that you can access, and those have their own top and bottom anchors. So in this image, let's say if we look at the playlist title at the top that says September, if I had just constrained it to the top anchor and I hadn't put that many pixels and it was actually smaller, then September would be behind that. Whereas the safe area, which is like the green part that blocks out that notch, and I set a rule to be below that by a certain amount, it would prevent me from accidentally putting it behind the notch. And then an example of how we do this in our code. Let's say I want to create a constraint to set the top edge of the green square to be 20 pixels below the bottom edge of the blue square. In order to do this, you would first access that green square, so green is view 2. I would do view2.topAnchor, so I'm accessing view 2's top anchor property. And then there's a method called .constraint that takes in these two parameters. So we'll call that method, and then we'll set equal to be view 1's bottom anchor because I'm setting a rule between these two anchors. And then constant is the amount that you want them to be apart by. So that's where you would put 20 for 20 pixels. Does that make sense to everybody? Cool. And then one more example. Let's say I want to create a constraint to set the top edge of view 1 to be 20 pixels offset from the top of our screen. And keep in mind that we have that safe area layout guide that we should be using when we want to do this. Can anyone kind of tell me like the process of thinking that you would use to write the line of code that would do this? Does anyone know what would come first? So before I said I want to set a rule on the top edge, which view would I start with? Yeah. So then I would do view1.topAnchor and then use that constraint property, and then what would that be equal to in the parameter? Yeah, so it's actually view.safeAreaLayoutGuide.topAnchor, but the correct thinking. And then once again, you put that pixel amount in the constant argument. All right, so now we're going to move on to our demo. We're going to build this like fake profile page for Bill Gates. There's no starter code because we're going to go over how to set up your projects from scratch because you'll be doing that for all of your assignments. So there is one thing that you guys should download on the website. There is a link to it on Piazza, or you can just go to the URL ioscourse.cornellappdev.com and then navigate to it in the chapters. It's under lecture demo for chapter 2, and it's just the file called Bill Gates. Cool. And then open Xcode. Oh yeah. So this demo is going to be pretty thorough because we have to go through a lot with like the setting up the project and setting constraints and everything. So if you guys have like general questions for like us that you want could help everyone, raise your right hand, and then if you have like a question about your code, like it isn't compiling or you're not sure what you did wrong or something, raise your left hand and one of the TAs will come help you. Cool. All right, so starting in Xcode, you can either go here to create a new Xcode project, because this time we're doing projects instead of playgrounds, or you can go to File, New, and do New Project. All right, so you'll get this thing to pop up, and you want to make sure Single View App is selected, and then hit Next. And then you'll have this field, and then in product name, this is what they'll eventually call your file. So when you guys are doing your assignments, you want to make sure this is where you set the file name accordingly. So we want you guys to be doing your net ID. So I'm doing my net ID _ P, and then the project number. So like for this week, since it's project 2, you would do P2. So that's the notation you should use for your assignments. I'm just going to change it to L2 because this is lecture. You guys can ignore the next 3 fields, / they should be pre-populated and it doesn't really matter right now. For language, make sure Swift is selected. And then for user interface, make sure storyboard is selected. And then you can leave the other 3 options unchecked. And then once you have all that, just hit next. Cool. And then you can just save it wherever you want and hit create. Cool. Did everyone get that? No? It's not letting you click next?
Kevin, you want to help?
Who's gonna go? All right. I can also just do that one more time if that would be better.
No, I think we need to fill in something.
Oh, you need to fill in something else. Which one is it? Oh, okay. So for if you guys have organization identifier like not filled out, you can just put whatever you want. Doesn't really matter.
I don't know what this one is. Com.
Normally, like syntactically, it's com dot something, but it doesn't really matter since we're not actually distributing this. Cool. Is that the confusion?
Doesn't have
If it doesn't, then it's probably an old version and it is by default storyboard. Cool. Any other issues? Awesome. All right, so you should already have some files here by default. I suspect some of you who are running different versions may not have all of these files. By show of hands, who doesn't have all of these files? 1, oh, it's not that many. 2, 3.
Okay. Well.
Are you guys not? Do you guys not have scene delegate? Yeah. All right. No.
Okay. We can go.
I can do both versions.
Okay.
All right. So we'll run through this 2 times. One for everyone who does have scene delegate. All right. So. Or actually, the first step is the same for everyone. You want to go to main.storyboard, right-click, and hit delete. And then move to trash. So that's on main.storyboard. Cool. All right. And then the second thing that I think everyone should have to do is go to info.plist and then go to the entry that says main storyboard file base name. And then this is really small, but they won't let me make it bigger. There's like a plus sign and a minus sign. Click on the minus sign to delete that row. Once again, that's main storyboard file base name. Cool. And now is where it'll be different. So anyone who does have scene delegate.swift already, this is what you should do. Also in info.plist, you want to go to application scene manifest. Open that up like as far as it'll let you, like all the way, expand it down. And then the last entry should say storyboard name, and you want to delete that one as well. And that's application scene manifest, expand the dropdown as far as it'll let you, and then delete storyboard name. Yeah, so I'll go over what you should do for that like version after this, since I think there's like multiple different versions of Xcode right now. All right, so
You have seen delegate and you still have that, you delete it too.
yeah, so if you have seen delegate, you should follow all the instructions I'm saying right now. So that's application scene manifest, expand it all the way, and delete the row that said storyboard name. Cool. Now, going back to scene delegate. So this is kind of like where your app will look to when it's first launched. So whenever the user like opens the app, it'll come into this file and look at this method. So it says func scene, and then one of the parameters is will connect to. And then we're just going to delete what's on line 20 for now. And we're going to start by doing if let window scene equals scene, and then as with the question mark UI window scene. So what we're doing here is we're using the if-let syntax that we talked about for optionals last lecture. And we're using that because we're trying to cast this scene argument, which is of type UI scene. We're casting it into a UI window scene. And in the case that it fails, it'll be nil. So we need to use the if-let syntax to protect against crashes. And now what we're going to do is create a window object. So let window equal UI window. And then do an open parentheses and select the autocomplete option that takes in a window scene argument. And then you're going to fill in the argument with the window scene variable that we just created here. Cool. So then one thing I want to mention is before when we did UI window scene, like without any parentheses, that means we're just referring to the type or the class UI window scene versus like if I were to have done UI window scene with two parentheses, that means I'm constructing an instance of this class, so it's like actually an object that I can use. Cool. So now that we've created a window that has this window scene parameter, basically you can think of a window as, once again, like the backdrop for your app. It's like the entire screen and encapsulates all of the views that are inside of it. The next thing you want to do is create an instance of ViewController. So you should already have this file called viewcontroller.swift by default. And like we mentioned in the slides, a ViewController is one single screen in your application. So I'm going to create an instance of my ViewController. I'm just going to call that variable ViewController. And then do ViewController with the parentheses once again because I'm creating an instance of it. Cool. And then what we want to do is kind of connect this ViewController to our window. So every window has a property called .root ViewController, which is the very base ViewController. So the first ViewController that shows up, basically. And then I want to set that equal to that ViewController that I just created, which I called ViewController. And then what we want to do is, if we notice at the top of this file, there's this instance variable called window. And what I'm going to do is set my personal window that I just created equal to this one, so they now refer to the same thing. So the way that we can refer to the instance variables or the properties of this class are with the self keyword. If you guys are familiar with, like for example in Java, you can use this dot something. This is analogous to doing that. So I do self.window equals window. So to reiterate, doing self.window will refer to the window up on line 13, whereas window here refers to the one I created on line 21. All right. And then the last thing is we want to do window dot make key invisible. So what this will do is literally just make your window visible because by default it'll be hidden. Cool. Now for anyone who didn't have scene delegate, you want to go to app delegate and then basically kind of do that same thing, but in did finish launching with options. So the first function in app delegate. So anyone who just did the stuff in scene delegate doesn't have to do this now. So it's basically the same thing. We're gonna do let window equal UI, but just UI window. Window with the frame.
Yeah, and then UI screen.
UI screen dot, alright, that's not screen. UI screen dot, alright. So before, alright, I'm not gonna talk about the differences because I feel like that'll get confusing. But then we're also gonna create an instance of our view controller doing this. I'm gonna set my Windows root view controller to that one. And then I'm also going to do window dot make key invisible. And then this one doesn't have it at the top. Alright, hopefully that works. Alright. And then self dot window equals window. Alright, sorry about that. Alright. So does now does everyone have either this in their app delegate or what we previously did in scene delegate? Alright. So now if we go into view controller, we're just gonna make this an arbitrary color so that when we run it and test, we can ensure that we got this set up properly. So inside viewController.Swift, do view.background color. I'm gonna make it blue just so I can tell that I set everything up correctly. Cool. And then once you've done this, you can run your project using the play button on the top left, or on your keyboard you can do Command R. And it doesn't really matter which simulator you're using. It'll take a while to boot up though. Oh wait, mine is gonna crash because I did it in both. Alright, I take that back. Alright, so does everyone who had app delegate have this now? I'm gonna just do that again. Alright, so I have this blue screen and that's kind of like a sanity check that I hooked this up correctly. Does anyone not have a blue screen? Oh, is it still loading? Alright, I'll give it a couple more minutes. Okay, are people still loading, or do we have blue screens now? Oh, is that a blue screen? Scene? Kevin. All right. Do we have blue screens for the majority?
So I got to the blue screen, but like, was the iPhone supposed to boot up onto the home screen and then open some app? And then show
Yeah.
the blue screen?
So basically, this simulator, any like project that you build onto it, you'll be able to open it from here. So then, like when you run your project, it'll like look like a new app is opening. Cool. Okay. I'm going to move on because we have a lot of stuff to do. Yeah. So now we've basically covered all of these setup steps. So these are the steps you'll have to do whenever you start a new project, because we're going to be using programmatic auto layout instead of other options that you can use to lay out your objects on your screen. And then the instructions for doing this are on the website, and I'll make sure to update them with the instructions for people who have the app delegate version. But we're going to move on to actually adding stuff to our screen so that we can start to accomplish this over here. So the first thing that we're going to do is I'm going to make this white because I don't want it to be blue anymore. And then this function that's already there by default, Viewdidload, this function is called every single time this view or screen loads for the first time, or every single time, not just the first time, into memory. So this is where you want to do any sort of like UI customization for setting up your screen. So something like setting the view's background color.
This is like a syntactical thing, but why do you put the dot before?
Oh, so this is actually like syntactic sugar for UI color dot white. And then like if I did dot, you'll see that. Oh, JK, they don't come up. It's kind of just sugar for doing that.
So does it know that it's a UI color?
Yeah, so it'll infer that. I think primarily because it's expecting that it's a UI color when you assign it to this property. Cool. Okay, so here's where we want to start creating all of our UI components. So the first thing that you want to do is your UI components you can think of as instance properties belonging to your view. So we're going to declare them at the top of our file like you would like class variables. So we're going to do var, and then I have a label, an image, a button, and then a text view. So I'm going to do name label of type UI label. And you'll notice that you are going to get this error that says class view controller has no initializers. And this error is complaining that you don't have any like constructors for your view controller that will provide a value for name label yet. So what we do is, this is one case where we may actually use the exclamation point because we know that we're going to create all of these UI components inside Viewdidload. So like as soon as this view controller comes loaded in from memory, we're assigning a value to it, so we should never run into any issues with that being nil. And then we're going to do the same thing with the image view, and then the follow button, and the text view that we had at the bottom. Oh. Well, we're setting those views. Cool.
What is it? Pretty much just says that you're guaranteeing that like name label, image view, all these will have a UI label or whatever their corresponding type is. It'll be created by the time the view is getting loaded. So by the end of Viewdidload, you're saying that there will be an object to replace this. But it's not being initialized until you go through the code. It'll be a little bit clearer when we start setting up the views.
Yeah.
So this is a similar question. Like before we define the variable type as an optional using a question mark, why are we defining it with an exclamation point here instead of like using an exclamation point later
So let me turn this on. This is working. We're not exactly force unwrapping. I kind of want to say you want
So
to.
if you make it optional, then anytime you type in name label, you're gonna have to do like the question mark. Like if you.
Yeah, so if I were to do this, and then I did like name label dot
Like anywhere we add this.
anything like that, you would have to like do question mark before that for
Well,
optional
But we
chaining.
know we're gonna initialize it in the Viewdidload, so we're just adding the exclamation point to say, don't worry about it. We'll make sure that there's a value for the variable.
Oh, so we're just making the program not complete.
Yeah.
Kind of, yeah, basically. Cool. So up here, I've just declared the types that I'll have all of these, but I haven't actually created these components yet. So what we're gonna do is now create them. And once again, we're putting this in Viewdidload so that anytime we load from memory, these will start to be created. So I'm gonna assign name label equal to a UI label. And then because I'm creating an instance of this, I'm gonna use the parentheses. And then the same thing for all of the other ones. So image view equals UI image view with parentheses, follow button equals UI button, and then text view equals UI text view. And then now that we've created them, we need to actually add them to our view. So every single view controller has this thing called a view, which is basically the rectangle on your screen that it manages. So if you do view dot add subview, you can pass in the components that you just created. So here I'm basically saying, oh, I'm adding this label to the screen. And then this line of code is very important for every single one of the things that you want to add to your screen, because if you don't do this, they just won't show up. And then view.add. My dot key is kind of broken. So does everything so far make sense to everyone? All right. So every single like UI component that you'll use, you can customize them, and they're all done a little differently. But if you kind of do enough, you'll start to like remember, or you can kind of learn to just like guess what the property might be, and then autocomplete will give you suggestions. So for something like a label, we want to set the text of our label to say Bill Gates, and then it has a property called text, so I'm just going to say the text this label says is Bill Gates. And then other common things that labels as well as other things might have are things like the color of the text. So text color. I just want this to be black, so I could use .black. And then for things like labels or anything that displays text, you can also do something with the font. So you can do UI font dot. Depending on the version of Xcode you may have different options for font. You can just pick one or just leave it as a default. So if you don't set these, they'll revert to default values. So the default text color is probably black. There's probably a default font. Let's just say I want to make it fancy and have a bold label for my name.
So fancy.
All right. So basically this is like similarly to anything, like you're just accessing these properties and setting them. Cool. And now if we ran our app now, we still actually won't see this label show up, even though we've added to the screen, we've configured like, oh, it should say Bill Gates, because we haven't set the size of it yet, and we haven't set its position on the screen with AutoLayout yet. So by default, Swift will think, oh, it's a size of like 0 by 0, and you won't be able to see it at all. So what we want to do is set constraints now. We're going to go through the elements one by one in case we run out of time, so that way like we go through the whole process for at least one UI component first. You could just start setting your constraints like in the same function here, Viewdidload, but in order to kind of like minimize how long Viewdidload gets, we can write just our own function that will deal with setting up constraints by itself. Set up constraints. And then make sure you call it at the end of setting up all of your UI components. So at the very bottom of Viewdidload, you'll call that function setup constraints. So I like to always call it as soon as I write the header, so that way I don't forget to put it there. Cool. And then inside setup constraints is where we'll put the stuff that we went over in the lecture slides. But the first thing that you need to do is NSLayout constraint dot activate, and you'll see this takes in a array of constraints, which are now like the lines of code that we went over in the lecture slides earlier. So let's just say I want to put this 15 pixels from the top of my screen. And by this I mean name label. So to reiterate, we do name label dot top anchor. Since I want to set a rule on where the top of it should be, I'm going to use the constraint function, and you'll see there's a lot of options. You'll tend to use 3 of them, but this is the one we had in the slides where it has an equal to and a constant parameter. I'm doing it equal to the top of my screen, so I want to make sure I'm using view.safeAreaLayoutGuide.topAnchor. And then I want to make it 15 pixels from the top of my screen. Oop, that's 16. Cool. And then I also want to make sure this label is centered horizontally on my screen. So you would do that very similarly. I'm going to do center X anchor and constrain that equal to the center of my screen. And this time, I don't want it offset from the center by any amount, so I'm just going to use the constraint method that has the equal to parameter and no constant parameter. So I'm doing it equal to my view's center X anchor. And then notice that since this is an array of constraints, we have a comma between each constraint that we set or we write. Does this make sense to everyone? All right. So now what we're going to do is, lastly, the thing that you need to remember to do is inside, going back to where we set up the views, we're going to do name label dot translates auto resizing mask into constraints. It's really long, really annoying, but if you go to the autocomplete and just hit enter, it'll do it for you, and set that to false. So what this means is Swift will try to like automatically infer like how big or small your object should be, and it'll like try to make those into constraints that will either clash with yours or kind of override yours. So if we set this to false, we'll make sure that the compiler will take note of our constraints and ignore anything that was inferred. Cool. So if we run this now, we'll hopefully see the name Bill Gates at the top of our screen. Yeah. All right. Is anyone's crashing? Yeah. Okay. Just raise your hand if you don't see the name Bill Gates at the top of your screen. Cool. So fatal error. If you're getting fatal errors, there may be one of 2 things that you didn't do. If you didn't do view.addSubview, you may be getting a fatal error. If you didn't call setup constraints, you might have issues right now. Or if you forgot to set translates auto resizing mask into constraints to false, you may have errors right now. So those are like the 3 common issues that come up with setting constraints.
Oh. Do what?
Translates auto resizing.
Oh, I did do that.
Okay. We're gonna move on to, I'm gonna ignore the image for the time being, and do the button because you're gonna have to deal with buttons in your project for this week. Image views are a little different, but if you look up the documentation, it should be pretty easy to follow, and I'll complete the demo and upload it and finish this recording and upload it after so that you'll have the whole thing. But we're gonna move on to the follow button because you guys are gonna have to use buttons. All right, so similarly to a label, a follow button can have, or a UI button can have text on it that is encapsulated inside this thing called a title label. And they actually provide you with methods to kind of modify the label directly instead of just accessing properties. So if you do follow button dot set title, you can pass in a string for its title. So I'm just going to say follow. And then for UI control dot state, this is an enum, and if you just do dot, you'll see all the options. So I just want my button to say follow in like any normal circumstance, so we're going to do dot normal. I'm also going to set my follow button's text color, and that's also with a method called set title color. I'm going to make it blue, and then also for a normal state. And then since I'm going to be setting constraints on this, I'm just going to make sure I do follow button dot translates auto resizing mask into constraints and set that to false right now. Cool. So now let's do one more thing. So all of these UI views may also have a property called layer. And layer, if you kind of look at the documentation that comes up here, it says it's the view's core animation layer used for rendering. You guys can kind of ignore core animation for right now, and just think of it as like another property you can access to set like visual properties for. So like layer has a border, and you can't just do dot border directly, but I can say like border color is equal to, and in this case we have to do UI color dot blue dot CG color and set like this entire chain directly instead of just using dot blue, because layer kind of takes on different properties than the properties directly. Sorry, that's kind of confusing, but kind of just, yeah.
Wait, what is CG color?
CG color is just another type for colors. So before we were dealing with UI colors, and then they can be just converted to like their CG color equivalent by doing .cg color. And then border color is expecting a CG color, so we just need to make sure it conforms. Yeah. And then let's just say I want to set the border width. That's also when we do .layer, and that just takes a value. So I'm just going to set it to 1.
Scroll up.
Cool. So now we're going to set some constraints on our button. And technically you could just add them to like the same array here and just keep appending to it. Just to make code more readable, you can just do another array, like do an array per UI component. And then I'm going to do follow button. I'm just going to put it below my name label. So similarly to what we did before, dot top anchor dot constrain equal to. I'm constraining it to the bottom of my name label, so I want to do name label dot bottom anchor. And then I want to offset it by just like 15 pixels again. I also want to make it centered on the screen like I did with the name label before. So I'm going to do center x anchor dot constraint equal to the views center x anchor. And then just to kind of demonstrate how you can do the anchors that deal with the sizing of objects, I'm going to do follow button dot width anchor this time. and you'll see there's another constraint function that's argument name is equal to constant. And this means you're not doing it relative to some other object, but I just want to make it like 100 pixels wide. Cool. Does that make sense? All right, so if we run this now, should have a button that is like a rectangle that says follow in it once you run it. I'll move this down. Oh. Cool. Some people have buttons now.
It's just supposed to be there. It's not supposed to be.
So because we haven't actually like set up anything yet, it doesn't really look like a button, but that's the next step. Cool. So right now, like, you're kind of probably thinking, oh, why is this different than a label? It just is displaying text. So the cool thing about a button, like you would expect a button to do, is you can assign a function to be run when your button gets touched. So we're going to do follow button, and the way you would kind of like hook up something is this method called add target. Whoa, add target. Cool. So add target, the target parameter, is basically associating this event with the element that's being pressed. So in this case, it's the button itself, so you can use the keyword self. We're going to skip over action for a second and go to the last argument, which is for. Once again, we see this dot event enum, so if you do dot, you'll get a bunch of options, but the one you'll typically do and the one that corresponds to just when a user like touches on a button is called touch up inside. So that's the one we're going to select for that last argument. And then action is where you're going to specify the function that you want to be run when the button is pressed. So the syntax for this is the hashtag and then selector. And you'll notice that it's asking for an at objc or Objective-C method. We'll go into that very shortly after, but basically this is where you would pass in the name of the function that you want to be run. So we haven't written it yet. So say I'm just about to write this function and I'm just going to call it follow button tapped. So you just pass in the name of the function to be run. It's going to error because we haven't written it yet, but we're going to do that very shortly. Cool. So that's add target. And now we're going to, so people can see this, I'm going to put it right here. So now we want to write the follow button tapped method. So we can do func follow button tapped, and it takes no parameters and it's just a void function. Now the thing that I mentioned before where it was asking for an at objc function, you just have to denote at objc in front of it. And that will hopefully silence any error you had on that line of code. Don't worry too much about what it means. Just remember you have to do that for anything you put inside that hashtag selector syntax. Cool. So what we want to accomplish when this button is pressed is have it change color and the text in the button. So going back to our code, we're first going to determine what kind of action this is based on like what text is currently in the button. So like if the button currently says follow, I want to change it to be following and change the color of it. And then if the button currently says following, I want to do the opposite so that I can do that. So let's do if, I'm ignoring the case for now. So if, and then since we declared all of these UI components as properties of our class, so like at the top of the file, I can just access name label, and then I can just check, not name label, follow button dot title label dot text, since I want to figure out what the text of the title label is, and then check if it's equal to follow. And then, so this is the case where I want to start following Bill Gates. So in this case, I need to first change the text. So similarly to what we did before, we're just going to use these functions again. Does anyone remember what the function for setting the text of the button is? Set title. Cool. Oh, that's color. Set title. And I want to change it to following. And then for the control state, once again, just the normal state. And now I need to do the same thing for setting the title color. Since now I want to change the color of the font to be white, once again for the normal state, and I want to change the background color. So we didn't do this before since the default color was white, but you can just access the dot background color property, and I'm going to make it blue since I want to fill in the button with that blue color when I follow him. And then the else case is I want to unfollow Bill Gates. So we're basically going to do the reverse action. So I'm just going to copy, paste to save time. And instead of, so this means my button currently says following. So I'm changing the title to follow, making the title color blue, and making the background white. All right, so does this logic make sense to everyone? Cool, yeah. Yeah, so if you just look at follow button.title label, you'll see that it's optional since it may or may not have text associated with it yet. So this is called optional chaining when you do the question mark before you keep doing stuff. Basically, it's like if it's not optional, continue. So now if we run this, and you click on the follow button, it should change to following. Cool. So in the project you guys have, you'll have to do something similar, but instead of kind of modifying the button that you just pressed, you have to modify other objects on the screen. And it's like a pretty trivial difference. You just will be accessing the properties of other components instead of just the button itself. But you could put any sort of other UI component inside your function that's your selector. Cool. So we are out of time, so I'm going to finish up the demo and then upload that code as well as like finish recording it and then let you guys know like the timestamp of when lecture ended and the extra content on Piazza.
Are you guys gonna start linking the lectures on the website?
Oh, we can do that. Yeah.
Yeah, we will.
We'll do that. Yeah, just as a final wrap up, make sure you're enrolled in Student Center. If you're not, you should be on CMS so you can continue submitting your assignments, and we're talking to administration to try to get that deadline fixed. Make sure you're in the Piazza so you get any announcements, and then Project 2 is on the website already, and it'll be due the coming Sunday at 11:59 p.m. Okay, so continuing on from where we left off in lecture, just to kind of
recap, we have this now. So we just have a screen that has a label and a button that we can tap to change the state of it, so the text and the color on it. So what we're missing right now is the image view, so the picture of Bill Gates, and the text view, which was just this really long chunk of text that just like displayed like a biography of Bill Gates. So there's really not much like novel content. So for an image view, we can set its image property to be the picture that we want it to display. So we can do imageview.image and set that equal to a UI image. A UI image, and since we're creating instance of a UI image, we need to use the constructor for it, and the one we want to use is the one that takes in a string name. So what you want to do now is go to the website and download this picture of Bill Gates. Oh, I already have one. And then go to this assets folder, and then this is where you store like any images you want to display in your app if you're storing them locally. And then go to your downloads or wherever you saved it and drag in this picture of Bill Gates. So I'm going to do the one that shows billgates.jpg, and then Bill Gates should be here in your assets. Alright, so now going back to view controller. So named of type string is going to take in the name of the file inside assets. So if I go to assets and note that this was called Bill Gates without any like uppercase. So here I'm just going to do Bill Gates spelled and capitalized the exact same way. Cool. And then something else we want to consider with images normally is imageview.contentMode. So what this is describe how your image will be like cut off or stretched to fit your image view. So the image view is basically like a container for any image, and the size of the image view doesn't have to match the inherent size of the image. So content mode has a few options. It's also an enum, so we can just use dot. And we see that there's a lot of options, but the ones you'll probably tend to use are the ones that are scale aspect, because those will maintain the aspect ratio of your image and won't like distort them in any way. And the one we normally want to use is probably going to be scale aspect fill. So what this does is it will scale your image up to fill the entire area of the image view and cut off any part of your image that no longer fits. And in order to make sure that cutting off takes effect, you need to do imageview.clips2bounds equals true. Cool. And now I'm going to set constraints on it. So I want to make sure I do imageview.translates auto-resizing mask into constraints equals false. Cool. So now I need to go into my setup constraints function, and I'm actually going to go and put it in between these two elements like we did in the screenshot of the demo. And I normally just like to keep these arrays of constraints in order. So I'm going to do .activate with the array again. Do imageview.top anchor, and I want to put it 15 pixels below my name label, equal to, that's not the right one, constraint equal to my name label's bottom anchor, offset by 15 pixels. And then I want to center it on the screen, which is what we've done a couple times now with the center X anchor. And then I also want to just set a width and height for this. So like we did with the follow button, we can do the width anchor, constraint equal to some constant value. Let's just do 200. And then I'm just going to make it a square, so my height anchor will also be a constant value of 200. Now I need to change follow button's top anchor here now, since I want to constrain it to be below. So right now this will put these elements in the same place, so they'll overlap each other and we won't be able to see one of them. So I need to just change this to be image view because I'm now putting it below image view. Cool, so if I run this now, we should have an image of Bill Gates. Oh, yeah, so Bill Gates, where we wanted him to be. Button still works. Yeah. Since we have extra time, since we're recording this after the lecture, I'm going to just demonstrate what would happen. So the actual file of Bill Gates was a square, so we can't really see the effect of our content mode here. But let's say I had made this a rectangle that was wider than it is tall. If I run this now, we'll see that Bill Gates, whoa, why are you blue again? Alright, I don't know what happened there, but we'll see that Bill Gates is now a rectangle, and he still fits my entire 200 pixel width, and the part of the image that got cut off just no longer shows up. The other option that we had for scale aspect was scale aspect fit, and what this does, it will scale your image so that the entire image will still fit in the container, so the image view, but the rest of the container will just be empty. So if I run this like this, we'll have this entire thing of Bill Gates, the entire image fit here, and basically it just looks like it's now this 100 by 100 square, but if I actually set the background color of the image view to be blue, we'll see that there's just a space in the container that's not being taken up by the image. Yeah, so that's a little bit about content mode. I'm gonna put it back to scale aspect fill and take away the background color and then make it a 200 by 200 square again. Cool, so that's everything about image views. And then the last thing we had was a text view. So text views are very similar to labels in terms of setting all the properties, since they just display text. But one thing that's the use cases for them are slightly different. As label implies, it's normally a short piece of text, 1 or 2 lines, whereas a text view can display multiple lines, many lines. And they can also be editable, so a user can click on them and change the text in them, which you can trigger through a property. That property is textView.isEditable, which you can just set to false or true. By default, it's false, so we're not going to do that. But yeah, so text view, so I can set the text of it. I want this to be really long just to demonstrate how it deals with really long text, so I'm literally just going to Google a Bill Gates biography. And copy paste this. And paste it here. Yeah, this is gonna be annoying. Just make it a really big chunk of text. Yeah. You guys don't have to do that, just type something. You guys don't have to make it really long, but this is just to demonstrate a text view showing a lot of text. Like we did with the labels, we can set the text color. By default, this is probably black, I want to say. And then another thing we could do is the alignment of the text. So I can do, once again, these are enum, so I can do .center. Actually, let's do justified because that looks fancy. Yeah, and if I wanted to, I could also set the font like we did with the label. But I'm gonna just stick with the default font. Cool. And then last but not least, I'm gonna do text view dot translates auto resizing mask into constraints to false. This is just a good thing to get in the habit of doing, and you could also just do it when you initially create it. It's probably the best idea. That way you just make sure you don't forget it. And then we're going to actually set our constraints. So this is going to be below the follow button. So the same syntax, NSLout constraint.activate to an array. and then set my constraints. So I want my text view to start, once again, 15 pixels below the bottom of the button. So I'm just going to do text view, top anchor is going to be equal to the follow buttons, bottom anchor, offset by 15 pixels. I want it to be centered on the screen like always, or like we've done for all the other elements. And then we're just gonna experiment with leading and trailing anchors. So let's say I don't want my like width of my text view to take up the entire screen, but I want some padding, like 15 pixels on both sides. So I'm going to use leading and trailing anchors to accomplish that. So I have a leading anchor. I'm going to constrain it equal to the view's leading anchor, offset by 15 pixels. And then I need to do the trailing anchor as well, equal to the view's trailing anchor. And then this is one thing to note. You can kind of think of like an iPhone screen as like a grid where the top left corner is like the 0, 0 coordinate. So as you go towards the right, you're like adding. So that's why for leading, I want this text view's leading anchor to be 15 pixels to the right of the view's leading anchor. So it's positive. But when I'm going in that reverse direction, it needs to be negative. So if you kind of like visualize these anchors on the screen, text view is left of the view trailing anchor, or at least when we're thinking about English, we're going left to right. So it's offset by a negative amount. Cool. And then one thing to note is that by setting a leading and trailing anchor, we've implicitly like set the width of the text view, so we don't have to set any sort of width anchor on it. Since we've basically set a rule on where it should start and end, it'll infer how wide it is based on those positions. And then lastly, I want to make sure my text view doesn't encroach the bottom of my screen, and I want to put some padding on the bottom. So I'm going to set the bottom anchor, constrained equal to, and since this is one of those special cases where it's the top or bottom of the screen, I want to use view.safeAreaLayoutGuide.bottom anchor. And then similarly to how going right to left in that reverse direction is negative, doing like a constraint from bottom to top is also negative. So let's just say by like -5 pixels. Cool. So now if I run this, we'll see that I now have this huge chunk of text that is cut off on the bottom here. It is actually scrollable. Oh, is this editable? Oh, so it's not editable by default. So I don't want anyone to go in and mess with Bill Gates' biography, so text view.isEditable equals false. Now if I run this, cool. We'll see that all of his biography didn't actually fit on the screen before the bottom. So this is where I set the bottom anchor of it to be. And it gets cut off right there. And by default, the label, or not the label, the text views are scrollable just because they're meant to display such large chunks of text. Cool. And now to kind of just like demonstrate the power, I guess, of auto layout like this. Let's say I change my mind and I want the Bill Gates label to be really, really large. So I'm gonna like double it or triple it. Let's triple it. If you had set all these manually with like numbers, you would have to go and like change the size of everything else to get it to fit on the screen. But now, since the constraints I set on my text view will literally just take up like whatever extra space the extra space on the screen is, the space allocated like in this bottom portion here for the text view has just like shrunk a little bit, and Bill Gates can still be that, and everything else still looks okay. Oh, I didn't triple it. I meant to do 60. Alright. Now if we do this, we'll really notice a difference. Yeah, so even if I made it like, if I made my picture bigger, let's say I made my picture 300 by 300, we'll just see that text view continue to shrink to accommodate like the change and constraints of everything else. Yeah. Cool. That completes this demo. If you guys have questions, feel free to post them on Piazza. And then make sure to look at the website for Project 2, which is going to be due on Sunday, I believe the 8th. Yeah, Sunday the 8th at 11:59 p.m.